Hi, I'm Hector Mireles from Cal Poly Pomona. I've been helping teachers this entire year through the RESPECT grant, and as promised, I'd like to explain a rather complicated system which is unavoidable in your lessons and for anybody who takes physics. This is involving things rolling down an inclined plane, such as this plane will have this car, ugly car. As you know, this car is eventually going to roll downwards. We know that. The reason why it rolls down is also pretty clear to us. There's a gravitational pull. Gravity pulls it down. But what do you do when somebody says the following? Here is an apple, and it falls downwards because a gravitational force goes downwards. We'll call that Fg, the force of gravity. This is easy to explain. An apple falls downward because it feels a downward force, also called weight, by the way, because the earth is down here and it pulls the apple downwards. So if a car on an inclined plane goes down because of gravity, why does not this go straight down? We know that the truck, in this car, the truck moves in this direction with a velocity v, but why is a force going downward a manifestation of, why does a force going downward cause a velocity in this direction? And for this I'm going to break this down from the very beginning. This is part of the lessons of the RESPECT spectrum, and for this the forces will be drawn in green, the acceleration will be drawn in red. Now we do know that objects accelerate in a direction proportional to the net forces acting on it. This is Newton's second law, says that an acceleration is proportional to the net force divided by m. But right now, let's just stick to this. An acceleration is proportional to the net force acting on something. Let's consider the apple now. An apple that's in the air feels only the acceleration of gravity, and that is straight down. In the absence of any other forces, the net force is as long as this one, and so the acceleration is simply proportional to the net force. We'll draw the acceleration in red, and so we have an acceleration straight down. Pretty clear. An object falling is accelerating straight down. For pedantic purposes, this acceleration in the world of physics is called a g. But it's an acceleration down, and it goes down because the net force is in this direction. All right. Now, let's go back to the inclined plane. Here is the inclined plane. And we can put here, again, a car. And we're going to assume that this car has very, very good wheels. So there is no rolling friction or anything like that. It's not going at 600 miles per hour, so there's no drag coefficient. It's just going to roll very perfectly. All right? Very good. Now, the question is why does this thing accelerate that way when the gravity that supposedly causes it is going straight down? Well, let's begin this in a simpler way. Let me first consider the same car on a flat road where there is no incline. All right, well, here was an object that's dropping through space. It feels a gravitational force, so let's give this thing, obviously this car has some weight, so there it is. The gravitational force is downwards. Whoops. Now, it's not the only force acting on this car because it's resting on the ground. It's different from this apple that's falling. So this car, like all of us standing on the ground, we feel a normal force going upwards. And the heavier we are, the greater this normal force must be. That's because these two equal each other in such a way that the net force is zero. The net force is the sum of this downward force and this force. They're equal to zero. How do I know that? Because the acceleration is zero. A car that is just resting on the ground, it doesn't accelerate upwards or downwards. So the net forces are equal to zero. This normal force equals the weight. Not so if the car is on an inclined plane. Let's take a look at what happens there. First of all, independent of where the car is, the car could be thrown up through the air or the car could be on the ground, it always feels the weight. And the weight always goes straight down. It may not seem like it, but even if you were to throw the car up into the air, the weight is always straight down. Why then does the thing go rolling off down the hill like this? Well, for that we have to consider what the normal force is doing. The normal force is that force that the ground pushes against something, which is trying to push against it, and this car is kind of leaning on this. The normal force is perpendicular to the surface, so it goes up like this. Now we all know that this car, it does not go digging into the ground, and it doesn't go floating up into the air. That's what would happen to the car if there were only one of these. But there's both of these forces acting on the same object. And the term net force would be the sum of all the forces acting on something, of which there's only two here. In our case, we have the normal force going this way and the gravitational force going down. If you were to add up these two forces, add up this arrow and this arrow, we can do that by taking this arrow and sticking it over here. We can always move a vector force around, that's what they're called. I'm just going to redraw this force and put it here. Lo and behold, we get a net force that is a total net force, which does go parallel to this surface. And now we see that the direction, not just of gravity, but the gravity combined with the normal force, leads to a net force parallel to the surface. And so the acceleration, which I draw in red, is this way. An acceleration, as you know, which I've been doing in red all along here, an acceleration is the change in velocity over time. So it's just the tendency for the velocity to increase. It means that this car will increase in velocity more and more along this direction. So, in closing, it is gravity that's pushing a car down a hill. It's just gravity is not getting the car to go completely in the direction that it wants to. It's only a piece of the direction. And if you consider this plane here, and you consider gravity going down here, one way of thinking about it is by saying that only a little piece of the downward force even goes in this direction. So that's another way of thinking about it. But more importantly, the acceleration is this way because the net force is this way, and the net force is not just gravity, it's gravity together with the normal force. I hope this explains a few things more for you. Thank you for your time.